So this is a projectile motion question where we're given a particle is projected with a speed of 7 root 5 meters per second at an angle alpha, where tan alpha is a half. Now when they give numbers in surd form like this, it generally means that something will cancel further on down the line, so we'll see where that will work out. We're told that it's projected, so we start maybe with a little diagram. So we've got a particle that's projected up like that maybe. I'll draw the horizontal plane in as well there, so the horizontal plane is something like that. And we are told that it's projected so that this is alpha and tan alpha is equal to a half. Well, when you're told that, always draw a little triangle just to fill in the details. A right angle triangle. So something like this here. We know alpha is there. If we know tan alpha is equal to a half, we can construct a triangle like it, and we can find out cos alpha and sine alpha. So when they tell you this, when they tell you that tan alpha is a fraction, you can use that fraction to work out cos and sine of the same angle, and then we'll be using that in a few moments to get the vectors we need. So always think SOHCAHTOA. Tan is opposite over adjacent, so that's the opposite over adjacent, so this would be 1, that would be 2. Then you can use Pythagoras' theorem to find out the hypotenuse, which would be the square root of 1 squared plus 2 squared, which is equal to the square root of 1 squared is 1 plus 4, which is root 5. Now that's kind of a little hint. You can kind of see where this root 5 will come into play then. So once you have the hypotenuse, you can then write out, and I'll do it in green here, we know that sine alpha is opposite over the hypotenuse. The opposite is 1 over root 5. And cos alpha is the adjacent over the hypotenuse, 2 over root 5. So now we've got sine, cos and tan. We know what the sine, cos and tan of all our angles are. So we can then use that, and I'll show you how. I might make a little, no, I'll leave it there. So what we need now, and I'll just maybe change the colour of the arrows. Instead of this vector written like this here, we need it in its I component and its j component. Now I component, we'll draw it along here, go along this way, and the j component would be made up of this vector here. So I'll do the I component in red there. If that's alpha, and we know the hypotenuse is 7 root 5, we know that, and when we're doing it, we know that cos alpha is equal to the adjacent over 7 root 5. It shouldn't be cos A, it should be cos alpha there, sorry. So we know the cos alpha is 2 over root 5. So we want to find out what what the adjacent, and that'll be the I component. So A, multiply both sides by 7 root 5. And then we have here cos alpha. I'll leave cos alpha there, but I'm going to substitute in now for cos alpha 2 root 5. So I have the adjacent component is equal to 7 root 5 multiplied by 2 over root 5. Luckily enough, the root 5s divide into each other there, and the adjacent component works out to be 14. 2 by 7 is 14. So I can write that in, and I'll write it in. So it's going to be 14i. Similarly, we can do the y component. I'll do the y component in green here. We know that sine alpha is equal to the opposite over the hypotenuse, 7 root 5. So the opposite side, I'll put a little p so it doesn't look like 0, multiply both sides by 7 root 5, we get 7 root 5 sine alpha. And remember that sine alpha is 1 over root 5, so we can substitute that in there. The opposite side is equal to 7 root 5 over root 5. They cancel, it's equal to 7. So what we've got here is 14i and 7j. There are two components. So that's the first question. the velocity vector, we could even write it in, the initial velocity is equal to 14I plus 7J. Now, I'm going to make a little bit of space here so that I can maybe continue on with this question below, so we can see how it's done now. Once you have that worked out, once you know this in its i's and j's components, it's quite easy to work out the next bit here. Now, for the horizontal range, we need to know how long is it going to be in the air. You get how long it's going to be in the air from the j component. That's the one that's like a stone being thrown vertically up in the air. Now we know that we're going to be using the v is equal to u plus at. V squared is equal to u squared plus 2as, or s is equal to ut plus 1/2 at squared. And we're going to be using that for the horizontal part here. That's the only part that's accelerating. The vertical part is the only part that is accelerating. The horizontal part stays at constant velocity. So we'll be using, fill in what we know. U is 7 meters per second. A is acceleration due to gravity, minus 9.8. We don't know, we'll work out what V is, we don't know what it is. We don't know what T, we can fill in what T is. That's really what we're looking for. And we don't know, well, we know what S is. When it's hit the ground, the displacement goes back to 0. Now there's two ways of doing this. You could find the time it takes for it to go up to its maximum height and multiply it by 2. So if it goes up to its maximum height, find that time, multiply it by 2. That's one way of doing it. But the other way, and I kind of like this other way a little bit more, is that if we use the third equation here and fill in what we know. So we know that S is 0 because when it falls back down, its displacement is in the y component is 0, is equal to ut, so it's 7t plus 1/2 at squared minus 9.8 t squared. Now, when we solve this, so we'll just multiply that in, we get 0 is equal to 7t minus 4.9 t squared. We can factorize out t. We get 7 minus 4.9 t. And another little bit of space there. And from this then we know that either S is 0, so this is the solution to this is when t is equal to 0, or when 7 minus 4.9t is equal to 0. So 7 minus 4.9t is equal to 0, that's the same as 4.9t is equal to 0, or 4.9t is equal to 7, or t is equal to 7 over 4.9. So I can just work that out quickly there. And I'll do that now. So if I just go 7 divided by 4.9 is equal to, so it's 1.42 or 1.43 seconds. So t, our time worked out to be, minimize that. Our time worked out to be, t works out to be 1.43 seconds. I'll leave it to 2 decimal places. Now, I know the time it takes for it to go up and down. I'll now be using the horizontal component of velocity to work out the distance. It's travelling at constant velocity in the horizontal component. I know the time. I know the velocity, u is 14 meters per second, time is 1.43 seconds, so all I have to work out is distance. Now I know velocity is distance over time. You could remember your speed, distance, time triangle for this component. So I know that the distance or displacement, I'll call it d, or maybe I'll leave it as s, is equal to the velocity multiplied by time. So it's 14 multiplied by 1.43, and again I'll just work that out quickly. If I go 14 multiplied by 1.43, it's equal to 20.02. So the distance that this has gone is 20.02 meters.